Today we'll be discussing the next type of chemical reaction, that is oxidation reaction and reduction reaction. Together the term oxidation and reduction, it is also said to be redox reaction. Okay? So first we'll be understanding the two terms oxidation and reduction. Okay? The word oxidation. Oxidation means, you can define oxidation in various ways. Okay. First, we can say oxidation to be the addition of oxygen. Like if oxygen is added, then it is said that oxidation is occurring, or it is an oxidation reaction. Okay. So addition of oxygen occurs, then it is an oxidation reaction. For example, we'll take in this case, suppose for carbon when it is combusted, okay, or in the presence of oxygen when it is burnt, it will give carbon dioxide. So here we say as oxygen is added to carbon, so this is the oxidation of carbon. Okay. So this is an oxidation reaction. For more example, you can take for example calcium on combining with oxygen, okay, it will form calcium oxide. So here we say that any reaction which involves addition of oxygen, then it will be oxidation reaction. Similarly, SO2, when oxygen is added to SO2, that is sulfur dioxide, then sulfur trioxide will be produced or formed. Okay, and this is again the oxidation of sulfur dioxide. Next example is the case of lead sulfide. Lead sulfide on oxidation, it will produce lead oxide, PbO. Okay, PbSO4, that is lead sulfate. So here we can say that lead sulfide is oxidized to lead sulfate. So all these reactions in which we see there is simply addition of oxygen, then they are the oxidation reaction. Okay. The next way how we can define an oxidation reaction is when hydrogen is removed. Okay. So you can say that the removal of hydrogen is also an oxidation reaction. So removal of hydrogen. If hydrogen is removed from any compound, then it is said to be an oxidation reaction. Okay. For example, H2SO4, when zinc reacts with H2SO4, okay, it will form zinc sulfate, ZnSO4 plus H2 gas. Here we say that the H2 gas is formed. It means hydrogen is removed in this case. So this is again an oxidation reaction. Okay. Another example is HCl. Okay. When it decomposes and it produces H2 and Cl2, then this is also an oxidation reaction. Here we see there is the oxidation of HCl. Here H2 is removed. Okay. So we say it is also a type of oxidation reaction. Okay. So all those reactions which involve removal of hydrogen, they are said to be oxidation reaction. Now these were the two terms in how we define oxidation. Okay. Now another way how we can define oxidation is very important and very essential way of expressing oxidation, that is in terms of the electronic interpretation. Okay, that is according to the electronic theory. Okay. So according to the electronic theory, we can say oxidation is basically the removal of electrons. Okay, so according to electronic theory, removal of electrons means there is oxidation occurring, and in any reaction if there are electrons being removed, or you can say from any element if electrons are removed, then there is occurring oxidation of that element or that compound. Okay. For example, we will see here sodium. It ionizes to produce Na plus and releases an electron. Here electron is removed from the sodium atom, okay, and sodium ion is formed. So this is a oxidation reaction. Here we see there is removal of electron. Okay, so this is an oxidation reaction. Similarly, if we say that zinc, it will form Zn2 plus and it will release 2 electrons. So this reaction in which we are seeing, or this step in which we are seeing that zinc is transformed into Zn2 plus ion, that is zinc ion, then it is said to be an oxidation reaction. Okay. So all these involve the oxidation reactions. Now from this we can make a definition of oxidation reaction. Now what will be the definition of oxidation reaction? So we can define oxidation to be a chemical reaction in which substance gains oxygen or loses hydrogen or loses electrons in terms of the electronic theory. So this is a, you can say, a short defined definition for oxidation. Now here we can see that as oxygen is an electronegative element and hydrogen is an electropositive element. So this definition can also be stated such as the chemical reactions in which an electronegative element is added or an electropositive element is removed or removal of electrons is involved, then it is an oxidation reaction. Now in our daily life we see many oxidation reactions such as the combustion reaction. It is the basic example of an oxidation reaction. So all the combustion reactions are the oxidation reaction, because combustion means burning in presence of oxygen. So here we see that is similar to oxidation. Okay. So if we relate with our daily life, we will see that all the combustion reactions, they are oxidation reaction. The rusting of iron, it is also an oxidation reaction. Okay. So these are few examples of oxidation reaction. So we'll take these examples. Examples related to our daily life are combustion reaction, combustion of any substance such as combustion of methane you say, then it is also an oxidation reaction. For example, CH4, that is methane, on combining with oxygen, it will produce carbon dioxide gas and water. So this is a oxidation reaction. Similarly, we can see other alkanes, they will also react with oxygen. They will combust with oxygen and they will form carbon dioxide and water. So all these are oxidation reactions. Now, respiration, it is also an oxidation reaction. Then we say rusting of iron. It is also an oxidation reaction. Here we say rusting of irons means when iron, when on long exposure to oxygen in moist atmosphere, that is in the presence of moisture, it will form rust, that is hydrated ferric oxide. Okay, so these are examples of some oxidation reactions related to our daily life. Now the next term is reduction reaction. Okay. What do we mean by reduction reaction? So this is just opposite of the oxidation reaction. Okay. So it will also be involving certain terms that we'll understand first. Okay. Now reduction. Reduction means either there is addition of hydrogen, there is removal of oxygen, or there is addition of electrons. Then it is termed as reduction reaction. First is removal of oxygen. Those chemical reaction which involves the removal of oxygen, they are said to be reduction reaction. Okay. For example, copper oxide, when it reacts with hydrogen, okay, it will form copper and water. Okay. So here we can see oxygen is removed. Oxygen is removed, and so this is a reduction reaction. Here we can say that copper oxide is reduced to copper. Okay. So there is occurring reduction of copper oxide. Okay. So we can say this term where copper oxide is forming, this term where copper oxide is turning to copper. Okay. Here there is occurring loss of oxygen or removal of oxygen, and this is termed as the reduction. So here we will say that copper oxide is reduced to copper. Okay. Now more example we can take similarly. Lead oxide, when it reacts with carbon. Okay. Here lead oxide, when it is treated with carbon, the carbon will accept this oxygen. Okay. And it will form carbon monoxide. So lead oxide will be reduced to lead and there will be formation of carbon monoxide. So here again we can say this is a reduction reaction. Okay. Here lead oxide is reduced to lead. So this part, it is said to be the reduction of lead oxide. Okay. Now in terms of hydrogen, we will define, it will be addition of hydrogen. Okay. Or we can say gain of hydrogen. Gain or addition of hydrogen. This will be also a reduction reaction. For example, H2S, when treated with chlorine, it will form HCl and sulfur. Now here we can say there is occurring reduction of chlorine. Okay, so here we can say chlorine is reduced and it forms HCl. Okay, similarly H2 plus O2, that is formation of water, H2O. Okay, this is again an oxidation or reduction reaction. Yes, it is a reduction reaction. Here we can say hydrogen, it is added to oxygen. So there is involving the reduction of oxygen. Oxygen is reduced. So in this case you can say that oxygen is reduced to water. Okay. Similarly, when ethene C2H4, it is hydrogenated, that is when hydrogen is added to ethene, it will form C2H6. Okay, so here we can say that ethene is reduced to ethane. Okay, so this is again the reduction reaction in terms of hydrogen. Now we can also define reduction as we have defined oxidation in terms of electronic theory. Now in terms of electronic theory, reduction is the addition of electrons. Okay. For example, chlorine, it has to accept an electron to complete its octet. So it will form Cl minus. Okay. And here as it is accepting electron, therefore this step or you can say this reaction is said to be a reduction reaction. Okay. So this will be a reduction reaction. Similarly, oxygen has to accept two electrons to complete its octet, okay, and to form O2 minus. So this is again a reduction reaction. Here oxygen is reduced to oxide ion. In the above case, chlorine is reduced to chloride ion. So we can say that this is the oxidation reactions and reduction reactions. All these reactions we have included in terms of the electronic theory. Now we'll understand these term oxidation and reduction together, and that is the redox reaction. But before that we'll see the definition of reduction. So if we have to define reduction, then it will be the chemical reaction in which there is a gain of hydrogen or loss of oxygen or addition or gain of electrons. Then those reactions are said to be reduction reaction. Here we have used the term hydrogen and oxygen. So more appropriately, if you want to define this reaction as hydrogen, it is an electropositive element and oxygen is an electronegative element. So this statement can also be written as chemical reactions in which there is a gain of electropositive element or loss of an electronegative element or gain of electrons, then it is a reduction reaction. So these are the two terms, oxidation and reduction. Now I am talking about the word redox. So these two reactions, they occur simultaneously, and so the next type of chemical reaction that we had to study, that was the redox reaction. Now we will be discussing about the redox reaction. As oxidation and reduction reaction, they cannot occur alone. Okay, they will always be occurring together. If there will be an oxidation reaction, then simultaneously there will be also a reduction reaction occurring place at the same time. Okay, so we have combined these terms and we have written the word redox. Now redox, red, red for reduction, and ox for oxidation. Okay, so now we will be studying the word redox together and we will see some examples how we say that these two reactions occur simultaneously. Oxidation and reduction reaction, they occur simultaneously. Either of them cannot occur alone. Okay, for example, if there is occurring oxidation, then there will be occurring reduction. For this, we will be seeing an example, that is copper oxide when it is reacting with hydrogen. Okay, it will form copper and H2. Here we see oxygen is removed. Okay, oxygen is removed, so there is occurring reduction of carbon, copper oxide. Okay, so this transformation of copper oxide into copper, this is the reduction of copper oxide. So we can see in this step there is occurring reduction. Okay. At the same time, what we are seeing, that hydrogen, it is accepting the oxygen. Okay, so here hydrogen, it is getting oxidized. So we can say there is occurring oxidation of hydrogen to water. So this is the oxidation. So in one reaction we are seeing the both the types of reaction occurring, and that is why it is called as the redox reaction. Okay. Here we see that copper oxide is reduced. Okay. So there is occurring reduction of copper oxide. It is reduced to copper. Okay. And the one which is reducing it to copper is known as the reducing agent. Okay. So here hydrogen is the reducing agent, as it is the reason for the reduction of copper oxide. Okay. So in this case we will say that copper oxide is reduced to copper and H2, that is hydrogen, is oxidized to water. Okay. Now, now we see that the substance which is bringing about reduction, okay, that is called as the reducing agent. So in this case, hydrogen is bringing about the reduction. So here hydrogen is the reducing agent. So the substance which brings about reduction is called as reducing agent. Here hydrogen is the reducing agent, and the substance which brings about oxidation is called as oxidizing. In this case, the oxidizing agent is Cu4, that is cupric oxide. So in the above case, we can denote that this is the oxidizing agent and this is the reducing agent. Similarly, we can see another reaction. For example, formation of NaCl. Okay, Na plus Cl2. It will form 2NaCl. Here we see there is occurring oxidation of sodium, okay, and there is reduction of chlorine. Okay. So here we see there is involving again the redox reaction. One of them is oxidized and the other is reduced. Okay, although there is formation of one product, we can see here we can denote it by their signs for Na plus and Cl minus. So in this case we can tell that there is occurring redox reaction. So here sodium is oxidized and the process involved is oxidation, and your chlorine is reduced and the process involved will be reduction. Okay. Now talking about the reducing agent and oxidizing agent, here the oxidizing agent, the one which is causing oxidation, that is sodium. Okay, and the reducing agent, that is the one which is causing reduction. In this case we can say that there is occurring oxidation of sodium. So the oxidizing agent, that is the one which is causing the oxidizing, is chlorine, and the reducing agent, that is the one that is causing the reduction of chlorine, is the sodium. Okay. So in this way we can explain the oxidation reduction reaction. Similarly, we can take another example of zinc and copper sulfate aqueous solution. Okay. When zinc is immersed in copper sulfate aqueous solution, we will see that there will be formation of a colorless solution, that is zinc sulfate, and deposition of copper. Okay. Now in this case also there is occurring the oxidation reduction reaction, that is the redox reaction. Here we see that Zn, that is zinc, it is transformed into Zn2 plus. So here there is occurring oxidation of zinc and the copper 2 plus, that is been reduced to copper. So there is occurring the reduction reaction. Okay. Now in this case, the one that is the oxidizing agent, that is causing oxidation. Now the oxidation is caused by CuSO4. So CuSO4, that is copper sulfate, will be the oxidizing agent, and zinc, it will be the reducing agent. Okay. So in this way we can explain the oxidation reduction reaction. Similarly, one more example we will take. that is of magnesium. When magnesium ribbon burns in oxygen, it will form magnesium oxide. Okay, here we see magnesium, it is formed into Mg2 plus ion, that is magnesium ion, and that is the oxidation of magnesium into its ion, as there is removal of electron, and oxygen is transformed into O2 minus, that is oxide ion, and so there it is the reduction of oxygen to oxide. So this is again a redox reaction. Similarly, who will be the oxidation and reducing reagents in this, agents in this? That is magnesium. It is causing the oxidation or reduction. It is causing the reduction of oxygen. So magnesium, it will be the reducing agent. Okay, and oxygen, it will be the oxidizing agent. So here we have completed our oxidation reduction reaction, that is the redox reaction.